Hi. So the last thing that we're going to go through in this part one of our exam review is inequalities. And there are a few things that we're going to focus on when we're doing inequalities. And the first one is just simple linear inequalities that we're going to graph. So whenever you're solving an inequality, you actually already know how. The only difference when solving a linear inequality is that when you're multiplying or dividing by a negative, you have to switch the direction of the sign. So here we have 2n plus 1 is greater than or equal to 13. You solve it just like you would any other equation, but it's now an inequality. So subtract 1, we get 2n is greater than or equal to 12. And then we have to go ahead and divide that side by 2, and so whatever you do to one side, you do to the other side. So we get that n is greater than or equal to 6. Notice the direction of the sign did not change because I did not multiply or divide by a negative number. N is greater than or equal to 6. So if you're graphing that on a number line, you really have to just think about what can n be. Well, n can be anything greater than 6. It can also be 6. So greater than 6 is on this side of the number line. So you go ahead and make an arrow showing that n can be anything going in this direction. Now we shade that dot at 6 to show that n can also be 6. And the reason we know that n can also be 6 is because we have this or equal to sign here. So n is greater than or equal to 6. All right. So here's another one. It looks pretty similar. So we're isolating the x. We add 3 to both sides. We get that 5x is greater than 50. And we divide both sides by 5. It's a positive 5, so the sign doesn't change direction. And we get that x is greater than 10. So again, since x is greater than 10, the arrow is going that way because it is bigger than 10. X can be anything over here, but x cannot be 10. So you have to draw an open dot to show that even though x is somewhat related to 10, it just cannot be 10. There is a hole in that spot because it cannot be that number. All right. So here we have one, and there is a negative sign involved. So let's see how that works. So we're trying to isolate the p. We subtract 15 from both sides, and we get that negative 7p is less than negative 63. Now we have to divide by negative 7, and notice I stress negative 7. We're dividing by a negative number here. So when we divide by negative 7, we get positive 9, but the sign changes direction, and that is key. That is super important to remember. Otherwise, your whole inequality is entirely wrong. It's the opposite of right if you forget to do that. So p is greater than 9, and coincidentally, the arrow is still going that way because p is greater than 9. And because it cannot be equal to 9, we have an open dot again. All right, so now it gets a little bit more interesting with my or here. So here we have two inequalities. I want you to treat this like two inequalities. So we have 9 plus 2b is less than 7, or 7 minus 5b is less than or equal to negative 8. So let's solve this part first, the part on the left. We're isolating the b, so we go ahead, we subtract 9 from both sides, and we divide both sides by 2, and we get that b is less than negative 1. Or, and since it was an or inequality, it still remains an or inequality, so it's either this or that. We have here 7 minus 5b is less than or equal to negative 8. We're isolating the b, so we subtract 7 from both sides. We get negative 5b is less than or equal to negative 15. And then we can go ahead and divide both sides by negative 5. Again, remember we're dividing by negative 5. We're dividing by a negative number, which means the sign has to change direction. And so b, therefore, is greater than or equal to 3. So it's this or this. When your answer is an or, that means it cannot be both. So either b is less than negative 1, and that's going that way, less than negative 1, so like negative 2, negative 3, so on and so forth, not including negative 1, or b is greater than or equal to 3. b is greater than or equal to 3. So when you have an or inequality, there is a space between. The inequality shoots out in both directions. It's either this or that. All right, hope that makes sense. All right, and so it's getting a little bit harder. This is now an and inequality. So this here is saying 10 is less than an equal, less than or equal to negative 12x minus 14. So that's true, and this is true as well. Negative 12x minus 14 is less than or equal to 34. I prefer, and this is just a personal preference, I prefer to separate this into two inequalities. So I have here this part of the inequality, that negative 10 is less than or equal to negative 12x minus 14. I have that right here. And then the other part of the inequality, negative 12x minus 14 is less than or equal to 34. I have it over here. And I'm going to go ahead and solve both separately. And then eventually it should work together. So isolate the x, we treat it just like an equation. Just remember that when you divide by that negative, you flip the sign. So we end up getting that negative 2 is greater than or equal to x. And on the other side of town, we're still isolating the x, so we add 14 to both sides. Then when we divide by that negative, again, remember that the sign flips direction. So x is greater than or equal to negative 4, which means that x is both greater than or equal to negative 4. It is also less than negative 2, which makes sense because that means it's between negative 4 and negative 2. So for those and inequalities, it's going to be in between two values. If this clashed, if it said that it was greater than negative 4 and less than negative 2, that doesn't make sense, and that would mean there's no solution. Hope that makes sense to you. Okay, moving forward. Here we have another one. This one was tricky because ours were all over the place. And it is easier, in my opinion, to separate the inequalities once again. So I'm going to use that as one inequality. It's over here. And then I'm going to use this side as the second inequality, and it's over here. And when you break it up into two parts, it's much, 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 much easier to handle. So now we have this. We're going to try and isolate the r. So I'm going to get my r's on one side. In order to do that, I added 4r to both sides. So I have 9r over here, but it's gone from this side. Then I went ahead and I subtracted 10 from both sides. So this is gone from that side. And so we have 9r is less than negative 27. And then I divided both sides by 9, and I got, this is not an n, this is an r. Anyway, and then I got that r is less than negative 3. All right, now on the other side of town, I did something similar. So I'm going to subtract 9 from both sides. And so the 9 goes away from that side. And we get this line here, negative 4r minus 26 is less than negative 2r. And again, remember, I'm trying to isolate the r, so I want all the r's on one side. I'm going to add 4r to both sides so I can get rid of it on this side. And I get that negative 26 is less than 2r, which is good because now I have a positive over here, so I'm not dividing by anything negative, so I'm not flipping any signs. So I'm going to divide both sides by 2, and I get that r is greater than negative 13, or negative 13 is less than r, whichever way you prefer to say it. And remember that this was an and inequality, so that means that r is both less than negative 3 and r is greater than negative 13. And since that does make sense together, we have our negative 13 here, r is greater than that, and it's also less than negative 3. And here is what our inequality looks like. All right, so that was our first inequality quiz. Now we have an absolute value inequality quiz. And it is an absolute value inequality is two inequalities in one. So remember that here we have 2n plus 1 is greater than or equal to 13. So it automatically makes that inequality the inequality that it looks like. but that absolute value means that it can also be related to negative 13. So in order to make your second inequality, you have to flip the sign to negative. Flip the sign to negative and also flip the direction of this sign. So now we have a second inequality, and we spoke about y in class. We don't have time to speak about it in this video, but just remember, to figure out your second inequality, you have to flip the direction of this and change the sign of this. So now our second inequality is 2n plus 1 is less than negative 13. Oh, and this should be less than or equal to, and so should this. This should be greater than or equal to. So that's a slight error there. Okay. Huh. What a shame. Anyway, so here we have both our inequalities, and we can go ahead and solve them. And we just learned how to solve inequalities. We just isolate the n. We get n is greater than 6, or n is less than negative 7. Now here's the thing. I'm saying or. Why or? Well, if n is greater than 6, can it also be less than negative 7? No, it's one or the other. So you want to, for this case, you don't actually have to write the or, but when you're graphing it, it will come out obvious it will come out as obvious what your answer is once you've graphed it. So n is greater than 6 goes that way, n is less than negative 7 goes that way, and that's why you know the answer is or. It's this or that because the answers are separate. Okay, so this one actually has no solution because it's saying here that the absolute value, which we know has to be a positive number because absolute value by definition is 0 and up. It cannot be negative. Absolute value can never be negative. Anyway, but here it is saying that absolute value is less than a negative number. Absolutely impossible. Absolute value cannot be negative, which means that there is no solution to this inequality. So let's keep going. All right, so here we have an inequality where the absolute value part is not yet isolated. Always before you start setting up your absolute value inequalities, make sure that your absolute value part is isolated. So we have to go ahead and add 4 to both sides so we can isolate the absolute value part of the inequality. So now we have that the absolute value of x is less than 11. So now from there we can set up both of our inequalities. Remember that one inequality looks just like this but without the absolute value sign. So x is less than 11. And the other one looks similar, but you have to change the direction of the inequality sign and change the sign. So we have that x is greater than negative 11, and that's our second inequality. So now, where do we go from there? Well, we're done. X is either less than 11, so going that way. Well, it's not either. X is also greater than negative 11, so going that way. These two things work together. When you graph it, you see that greater than negative 11 and less than 11 means that it's both are happening simultaneously. So x is between. So I have it written this way. I could also have written it as negative 11 is less than x, which is less than 11. All right, let's keep it moving. All right, so here we have in question 5, the absolute value part is not yet isolated, and we just learned that in order to solve these, we have to first isolate this part, this absolute value part. So I'm going to go ahead, treat it kind of like an x, like one variable. Treat this whole thing as if it's one variable. And so we have to subtract 1 from both sides, and we get that 3 times this absolute value is greater than 4. We still don't have that isolated, so we can go ahead and divide both sides by 3. So we divide this by 3 and then this by 3, so we get that this absolute value part is greater than 4 over 3. Now we have our absolute value part isolated, which means now we can set up both of our inequalities. So one of the inequalities will look exactly like this, but without the absolute value signs. So we have that one here on the left. The other inequality will have opposite signs here, so it becomes negative 4 over 3, and you change the direction of the inequality. So that's over here. Okay, so now we can go ahead and solve both. We've solved so many equations on inequalities so far, so I'm going to trust that you know how to do that. And when you do that, we get that x is greater than 10 over 3, or 3.333 if you use your calculator. We also get that x is less than 2/3. So if you graph that x is greater than 3.333, it goes that way. You graph that x is less than 0.666, it goes that way, which means it's either this or that. So that's how we know it's an or inequality. And here we have an absolute value inequality, and as you know, when you see this part, always isolate it first, and then you can solve. So we try to isolate that, or we isolate that. We subtract the 3. We get that this is greater than or equal to negative 12. We divide by 7, and we get that this absolute value is greater than a negative number. Well, absolute value is always greater than a negative number, because absolute value is always positive or 0. So because it's saying that absolute value is greater than a negative number, since that is like obviously the fact, regardless of what x is, doesn't matter what x is, anything, x can be absolutely anything, the absolute value will always be greater than negative 12 over 7, which means they're infinite solutions. All right, so the graph goes infinitely left, infinitely right, and that's what the graph looks like. All right, and now, by the time I got to quiz 22, I was so tired I started to think upside down, and that's okay. And this is the last quiz, so let's go over it. And everything you see in red is the actual answer. What you see in black is the fake I was tired answer. All right, so now we're going to be graphing inequalities, but with 2 variables instead of 1. So it's just like graphing linear functions, but then we have to shade the side of the inequality that is correct. So here we have y is less than or equal to 2x plus 3. The first thing that we would do is graph the linear function y is 2x plus 3, or y is equal to 2x plus 3. So our y-intercept is 3, we would start there. Our slope is 2, or 2 over 1, so it rises 2 and runs 1, rises 2 and runs 1. And then we would draw our line. And this line is actually a part of the solution because, as you can see, y is less than or equal to that line. Now, here it says y is everything below that line, so y is less than or equal to. So that means the solution is everything below this line. So I look at my line, and I can shade the solution below, and everything that you see here in red plus the line is my solution. All right, so we can go ahead and try that again. As you can see here, now there is no or equal to. So we're going to have a dotted line when we have no or equal to. So the line y is equal to this doesn't count, but we still do have to draw that line. So we go ahead. Y is, let's say, okay, so the y-intercept is negative 1, so we would start at negative 1, and the slope is negative 1 over 3. So we rise negative 1, so that means we actually fall. So we go down 1 and over to the right 1, 2, 3, and that's our next point. We go down 1, then 1, 2, 3. Remember, only one of these values is negative, so if we go down, we are going to the right. All right, and so just make sure your slope is negative here. And that was a big error a lot of people made. Okay, so once we have that line, that dotted line drawn in, we have to decide which side are we going to shade. And it says y is greater than this. So that means y is above this. Y can be anything on top of that. So that's why we have to shade the red on top. All right, almost there. So now we have y is less than 2, and hopefully we recall that a horizontal line, or a line y equals something, is always a horizontal line. So here, horizontal line at 2 is y equals 2, but it is a dotted line. The reason it's a dotted line because y cannot be equal to 2. but we still have to draw that dotted line here. And it says y is everything below that line. Y is less than 2. So y is everything below, and so the black is actually shaded correctly here. All right, now here looks a little bit more tricky, but it's not too bad. First, we have to isolate the y, and I did it down here. So I went ahead and I moved the y over here, and then moved the -1 over here. It's like I swapped places and the signs of those two things changed. So we have y is less than or equal to -3x plus 1. And of course, that's our y-intercept, so we can start at 1. And our slope is -3 or -3 over 1. So I went up 3, 1, 2, 3, or to the left 1, or I could think of it as going down 1, 2, 3, and to the right 1. So just make sure that your slope is negative, because that's a common error and I don't want anyone to make that mistake. All right, so once you have your dotted line, which should not be a dotted line, doggone it. All right, so once you have your line, it should be a solid line because it's or equal to. We shade the other side. We shade below because it says y is less than that. So we shade below, and that is our solution. And our extra credit was a lot of fun here. All right, so that's what the solution looks like. Let's talk about y. All right, so y is greater than or equal to, sorry, that's an x. X is greater than or equal to 0. Remember that this is a horizontal line. X equals 0 is a horizontal line at 0. So x is greater than or equal to 0. Well, that's x is 0. And everything shaded lightly in black is x is greater than 0. So that's what that looks like. Now just keep in mind that the solution of a system of linear equations is what gets shaded every single time. So what gets shaded here, what gets shaded here, and what gets shaded here. And it being a system of 3 inequalities made it super harder than it would be if it was 2. All right, now as far as this, y is less than x. Well, that's like saying y is less than 1x plus 0. Our slope is 1 and our y-intercept is 0. So, or we could use even a t-chart. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. So the line at y is equal to x looks like this, going straight 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, so on and so forth. We have a straight line going down here. So that is the line y equals x, and we are graphing y is less than x, so we graph below that line. And I shaded it in orange really lightly. You may see it, maybe, or maybe not, but that is where I'm shading. And finally, we have y is greater than or equal to, I believe this is 1/4 x minus 1. So I have here, that's my -1, my -1, no y-intercept. Rise 1 over 1, 2, 3, 4. So that's my line, and y is greater. So as you can see, the solution is the area that I shaded 3 times. That was kind of challenging, but hopefully you understood, and I believe that's the end of our packet. Yes, everything else in this packet is on part 2 of our final, so hopefully this helped, and good luck.